All right, let's talk about subnetting. Specifically, what's the big idea? It's a word I say all the time. I talk about subnets all the time. What are subnets? What are we talking about? So what is subnetting? Why would you want to have multiple subnets? Why do we even care about the ability to create these subnets? What are subnets anyway? And then finally, how do you create them? What is the, binary, numbery process for making subnets out of a network? So subnetting is dividing a block of IP addresses into smaller chunks. It's taking one big network that you control, dividing it into smaller sub-networks, get it? Subnets, that you control, to create a bunch of different networks out of one big network. And why would you want to do it? Who cares? What's the big deal? For one, you get more control over what goes on your network. By splitting things up across multiple networks, putting routers in between them, you have control over who can talk to whom and how and when and why. And that gives you a little bit of a measure of security because you can put firewalls in there that control who has access to what. And this is especially important for servers, things like that you want to have a little bit more control over who can access it and when and how and all of those things. And then finally, another big reason, and maybe the biggest, is to reduce network congestion. The bigger a network gets, the more traffic there is on the network, and the more traffic there is in the network, the more you run into issues potentially with network congestion. And Ethernet is specifically optimized and typically maxes out in efficiency at about 256 hosts on a network-ish, 250-ish. And if you get much bigger than that, if you end up with 1,000 or, let's say 16 million hosts on one network, the entire network would shut down. You would not be able to do anything, and it just simply wouldn't work anymore. So we need to be able to split networks up, put routers in between to reduce that congestion by limiting the scope of each of these networks using those routers. So how do we subnet? What is it? We're dividing networks up. What does that even mean? Let's talk about it with an example. Let's take a network, an address block that we control. And we're going to start just using this private address block of 10.0.0.0/8. It doesn't have to be a private address. It could be a public address. It could be any block that you want. We're just going to start here because you see these a lot. You see 10.0.0.0/8 subnetted a lot. So what do we know about the 10.0.0.0/8 subnet? Well, that's one network. That's one network that has 8 network bits, 8 bits dedicated to the network address. That first byte is all for the network address, and 24 bits for the host addresses, which means 24 bits worth of hosts, minus 2, right? Because you've got the network address and the broadcast address. But that's 16,777,214 hosts on a network. And remember what I said about congestion? If you got 16 million things on one network, that's bad for congestion. So we're going to have to split that up. And there's a whole bunch of ways that we can split that up because we have 24 host bits that we're dealing with. So if you look at the addresses that are on this 10.0.0.0/8 network, 10.1.2.3, 10.50.33.218, 10.255.255.254. All of those are potentially host addresses on one giant network. That's too many. It can't work. It leads to congestion, so we need to split it up. So subnetting is the process of taking that giant network, splitting it up into smaller networks, and we do that by taking some of those host bits. Remember, we have 24 bits of host information, I guess. We're going to take some of those, we're going to shift them from the host over into the subnet mask and use those bits to create new subnets. And it creates those subnets within the address space that we already have. So the 10.0.0.0/8, that's our space. That's what we control, and we can do anything we want with the addresses that start with 10. So let's split them up and make a bunch of smaller networks within that. So for example, let's say we wanted to make 10.0.0.0/16. /16 it's still within our 10.0.0.0 network. Everything's going to start with 10, and anything that starts with 10 is within that network. So we have 8 new bits for the subnet mask then. Remember, it was /8 before, now it's /16. That means we've moved 8 bits from the network, from the host side over to the network side. And by doing that, we have created 256, which is 2 to the 8th. Remember those 8 bits that we moved over, 2 to the 8th subnets. And those subnets are 10.0.0.0, 10.1.0.0, 10.2.0.0, 10.3.0.0, 10.255.0.0. All of those networks in between, from 10.0 to 10.255/16, are all subnets there. So we can have one network somewhere in our network that is 10.1.0.0/16 and have a whole bunch of devices on there. And then somewhere else in the network, we can have 10.2.0.0/16 with a whole bunch of devices on there. And each of those subnets can have 2 to the 16th, because we have 16 network bits now. That means that leaves 16 host bits, which means that we can have 2 to the 16th minus 2, which is 65,534 hosts on those networks. Now the trick about this is you don't have to use them all. So we've created 256 subnets with 65,534 devices on each subnet. You don't have to use all of those addresses, but you have them. So if you needed 250 subnets, that's okay. You would still, use this subnet mask and just have 6 subnets that you're not using. If you needed 100 subnets, you could do it this way and have a whole bunch of subnets that you're not using. You don't have to use them all just because you create them. And that's particularly important for this number here, this 65,534, because if you, again, we're capping out at about 250 hosts on a network. Once you get more than that, then you lead to congestion issues. 65,000 is quite a bit more than 250. So that's one way of splitting up this network, but it's not the only way. You've got options. You've got 24 host bits to play with. Let's say you wanted to split this up in a different way and make it 10.0.0.0/24 and add 16 bits of host addresses, host bits over to the network side. Let's say you wanted to do that. How would that work? So we take those 16 bits. Remember, originally our network was 10.0.0.0/8. Now we have /24, which means we've moved 16 bits over, which means we have created 65,536 new subnets because we took those 16 bits over. So we have 16 bits of subnets that we can create. And those subnets are 10.0.0.0, 10.0.1.0, 10.1.0.0, all the way up to 10.255.255.0/24. So we have a whole bunch, 65,536 to be precise, because we have 16 bits of subnets moved over. That's a lot. Each of those is quite a bit smaller than the last one because there are only 8 host bits left. Remember, we can look up here at our subnet mask /24. 32 minus 24 is 8. That leaves us 8 bits for hosts. 2 to the 8th minus 2 is 254 hosts per network. So we have 65,536 different networks, 10.0.0.0, 10.1.1.0, 10.0.1.0, 10.5.5.0, every number in between, with 254 hosts per subnet. And remember, once again, you don't have to use them all. You don't have to use all the subnets. You don't have to use all the hosts on each subnet. It's just a way to split things up and make things a little bit more efficient, make your network function a little bit better for security, for control, and for congestion reasons. So let's do one more example, and this time we're going to use public addresses because 10.0.0.0, that's our private address space, but let's do a public address space example, just a fairly simple example, just to talk about how that might work. So if you were an organization and you had purchased this Class B address block of 128.187.0.0/16, you control all of 128.187.0.0/16. And let's say we have this network and we want to split it up and we want to create 300 subnets. How do we go about doing that? How would we divide this up? So let's say you had 300 different buildings or 300 different areas on your organization's campus that you wanted to be able to service with these subnets. How would you decide what to do? How would you make up your mind? So remember, 128.187.0.0/16, our goal is 300 subnets. So if we took 8 bits from the host side, from the 16 bits of hosts that we have, move them over into the subnet, that gives us 2 to the 8th or 256 subnets. But we needed 300 of them. That's not enough. So we need one more bit. And if we add one more bit to our subnet stuff, then we have 2 to the 9th, which is 512 subnets. So we need 9 subnet bits, which means we need to move 9 of the bits from that 16-bit host area over into the subnet area. And what are we going to do? We're going to then add that 9 to the 16 to make our subnet masks /25, because that's 16 plus 9, so 9 more bits in the subnet mask. And that gives us all of our addresses. Using that magic number, you can figure out what your network addresses are going to be. You know that everything that starts with 128.187 is in your control. And so we start with 128.187.0.0, and then 128.187.0.128, and then et cetera, et cetera, et cetera, et cetera, all the way up to 128.187.255.0 and 128.187.255.128. And all of those are in your control. So you have those 9 bits in the subnet mask that are dedicated to your subnet, along with the original 16 for your network. And that gives you, if you got /25, 32 minus 25 is 7. 2 to the 7th minus 2 is 126 hosts per subnet, which is still pretty big, plenty large for lots of things, so you just have to split things up and decide what you're going to do with them from there. So before you go, check yourself. How do you create subnets from a larger network that you control, and what determines how many subnets you can? What are the factors that determine how many subnets you can create from your larger network into those smaller networks?